Good morning. This video is about solving two-step equations with a square. So, our objective is I can solve two-step equations involving squares. In order to do this, the success criteria says I can solve two-step equations, I can understand that the inverse of a squared number is the square root, and I can estimate square roots. So, take out your notebook. You're going to need to start taking notes in your notebook. Title it Equations with Squares. Okay, this is problem number 1. I'm going to show you my thinking process. Make sure to write it in your notes. Everything that I write down, you write down too. The first thing I'm going to do here on this equation 3x plus 5 equals 10 is I'm drawing a line down the equal sign to help me remember that what I do to one side, I have to do to the other. Then, the main goal for solving an equation is to isolate the variable, which means that I need to get x by itself. So, what's not attached to the x is the plus 5. It's on the same side of that equal sign. So I have to move that plus 5 over to the other side. And in order to move things to one side, I have to use inverse operations. And in this case, the inverse operation of plus 5 is minus 5. So, I'm subtracting 5 from both sides. That means that on my left, I'm left with 3x, and on my right, I'm left with 5, because 10 minus 5 is 5. Now, I have 3x equals 5. Remember that when you have a number right next to a variable, it means multiplication. So, the inverse of multiplication is division. So 3x divided by 3, and the other side I'm also dividing. Then I'm left with x equals 5/3. And I'm going to leave it as a fraction, and there's my answer. This is a review of two-step equations. So let's try something a little bit different. We're actually going to start talking about equations that have squares in them. So do you remember this number line that we've been working on where we have the whole numbers and then we have their square roots that are equal to them? This is going to be really helpful for today's lesson. So just a reminder that we have our number line here, and what this means is that 1 squared equals 1. That is why the square root of 1 equals 1. It's the inverse. So that's not a great example because 1 is a special number. But let's try 2. Remember how I said the square root of 4 is 2 because 2 squared equals 4. Okay? So this is the whole purpose of this number line, of we're trying to find the equivalency. So let's keep on going. Square root of 9 is 3 because 3 squared is 9. Okay? So that's the whole purpose behind it. And we have to know this inverse relationship between squares and square roots to help us with our equations. So if I have the square root of something, that means it's the opposite of having an exponent raised to the second power. Okay, let's try problem number 2. This is my thinking again, and I need you to take notes in your notebook. So we're going to solve the equation for a, and our equation is a squared plus 5 equals 30. So the difference here is that we actually have a variable that has an exponent, and specifically an exponent of 2. So same process. I'm going to draw the line down the equal sign. Then I'm going to get rid of the constants that are on the same side as my variable. So I'm going to get rid of that positive 5, that plus 5, by subtracting 5 from both sides. And I'm left with a squared equals 30 minus 5 is 25. Okay, so here we have a squared equals 25. And this is the new thinking, the new learning that's happening, is our objective. We have that squared exponent, which we need to get rid of. And in order to get rid of it, to isolate the a all by itself without exponents, we're going to use the inverse relationship of squares, which is the square root. So I'm going to use a different color. If you have a different color that you can use, I would suggest that you do that. If you don't, then you might want to do this as a separate step. So I'm actually going to take the square root of both sides. So I have now the square root of a squared equals the square root of 25. So the square root and 2, those cancel out, and I'm left with a equals, and then the square root of 25 is 5. So my answer is a equals 5. All right, let's try another one. Problem 3. In this case, we're going to solve the equation for b. And our equation is 12 plus b squared equals 112. Okay, so first thing, draw that line down the equal sign. Second thing, I need to get rid of that 12 to get b squared by itself. So it's a positive 12. That means I'm subtracting 12 from both sides. On my left, the 12s cancel out, and I'm left with b squared equals 112 minus 12 is 100. Okay, for those of you who don't have a different color, this is how I would suggest that you write it. So I'm going to actually write this step again. B squared equals 100. And on this step, I'm going to take the square roots of both sides. Okay, so that's actually what I'm doing. I'm taking the square roots of both sides. That means the exponent of 2 and the square root cancel out. I'm left with b equals, and then the square root of 100, what's that equal to? You got it. It's equal to 10. So b equals 10. Okay, let's try another one. What happens if we don't end up with a perfect square? So this is problem number 4. I have 15 plus b squared equals 132. Okay, so again, I'm going to draw that line down the equal sign. I'm going to subtract 15 to get b squared by itself. So on my left, I'm left with b squared equals, and then I have 132 minus 15. If I subtract that, I get 117. Okay, now I have to take the square roots of both sides. Okay, so the square root and the squared cancel each other out. I'm left with b equals, and now I have the square root of 17. If you guys notice, the square root of 17 is not on my number line, but I know that it falls somewhere between 10 and 11, because it falls between the square root of 100 and the square root of 121. So this is where we can estimate out that the square root of 117 is going to fall between 10 and 11. Okay? Let's see. 117 is 4 away from 124 and 17 away from 100. So it's definitely way closer to the 11. So I'm going to kind of guess and say it's going to be around 10.9 maybe? Maybe 10.8. Yeah, let's do 10.8. I think that's, because there are 4 places. Okay. And that's my answer. I'm just estimating. It's not going to be perfect, but it is what it is. Let's try one more. I want you guys to try this one. Pause the video. Try this one on your own. The equation is a squared plus 7 equals 50. All right, welcome back. Let's go ahead and try it. Draw that line down the equal sign. Okay, I'm going to subtract 7 from both sides to get a by itself. And I'm left with a squared equals 43. Now I have to take the square roots of both sides. Squares cancel each other out, and I'm left with a equals the square root of 43. which, let's estimate that out, is going to be between square root of 36 and square root of 49, which is between 6 and 7. On that number line, let's see, 43 is 6 away from 49 and 7 away from 36. So it's going to be kind of in the middle. So let's say, but it's a little bit closer to 49. So I'm going to estimate it to be 6.6 or 6.5. Okay. For these, we will definitely, take either one. Okay. Now, when we start actually using this concept in our work, when we talk about Pythagorean theorem, which I'm really excited about, we'll actually get a calculator, so we won't have to estimate as much, but today you will have to estimate. There's no calculator today for your work. Okay, so go ahead and do the practice problems on Desmos. I want you to try to solve the problems on slide 4 through 6. Then if you finish early, try the challenge problem starting on slide 7. And yes, if you have time in class and you finished slide 6, then I want you to do the challenge problems, okay? Have a great day. After the challenge problems, if you're done with those, then there is some IXL for extra practice on rational and irrational numbers.